this is part 2 of our research and development lecture. Now we're going to talk about a couple different research designs. The first is called longitudinal. This is a study conducted on the same participants over a long period of time. So maybe you're interested in how something changes in children, so you follow the same children from the ages of 4 till the ages of 10. That's a longitudinal study. The pros of this type of study is it eliminates some confounding variables. Since you're looking at the same people, you can see the effects over time. The cons are it's expensive, it's time consuming. People drop out of your study, circumstances change. The longer a study goes, the more likely someone might drop out, the more expensive it becomes. So the opposite of this is a cross-sectional study. This is multiple groups of participants measured in a short period of time. So maybe you did the same study, but now you measure a group of 4-year-olds, 6-year-olds, 8-year-olds, and 10-year-olds. So instead of following children from the age of 4 to the age of 10, you just measure a bunch of children who are different ages at the same time. The pros of this is it's cheaper and faster, you can see group differences, and it's more likely that all your participants will finish. The cons are it can be harder to isolate variables. Maybe one group has something different about it than another group that you aren't measuring. So you have to be careful of that because you're looking at more people. A mix between the two is called a cross-sequential. These are rarer. You have multiple groups, but you look at them over time. So maybe you have a group of 4, 6, and 8-year-olds, and you measure them each over a period of 2 years. So that would be cross-sequential. It averages the pros and cons of the other two research designs. In psychology, you'll most likely see longitudinal and cross-sectional. Cross-sequential is rarer. Ethics in human research. We're studying humans. Psychology is a difficult science because we're not studying machines or parts. We are studying people. And so we have to consider ethics. So there's a few major things you have to consider when you're researching humans. First is protection from harm. It's just what it says. We have to do everything in our power to ensure participants suffer no harm while participating in our study, physical, emotional, or mental. We have to keep our participants safe. We have to do something called informed consent. All participants must sign an informed consent before they are allowed to participate in your study. They must be told the purpose of the study to the extent that it doesn't give away the hypothesis or bias your results. They need to be told what they will be expected to do, and they need to be given all their possible risks and benefits. And they have to agree to be in your study before they are allowed to participate. Participants must also be given the option to say no or stop at any time, even in the middle of your study. People under 18 cannot give informed consent. Children still have to agree using something called a child assent, but a parent or a guardian has to give the consent. So when you're studying child development, you have to get consent from the parents or the guardian. People who are mentally incapacitated also cannot give informed consent. Privacy. We have to ensure the confidentiality and/or anonymity of participants. We have to make sure that their personal information stays private and that nothing you do can compromise their privacy. We have to consider something called a benefit to risk ratio. Do the possible benefits of the study outweigh the possible risks? You see this especially in drug studies when they're trying to test out a new drug and they give one group a placebo. Well, the people taking the placebo have a lot of risks because their disease isn't getting treated. But the possible benefits of finding a cure or a treatment for a disease outweigh those risks. So you have to weigh the benefits and the risks to decide if the study is worthwhile. We also have to consider protected populations. There are certain groups that require extra care from researchers. Children are one of those groups. Other groups are pregnant women, people who are mentally incapacitated, prisoners, etc. There's a whole list of protected populations. And whenever someone studies them, you still can study them. You just have to take extra precautions. You have to take extra care to be sure they're being treated ethically. There are a lot more issues with ethics, but we won't go into them all. Before conducting human research, you have to get certified, which means you understand the ethics involved. And every study has to be approved by something called the IRB to make sure that it's ethical before you're allowed to proceed. So why do these strict guidelines exist? Well, there's some famous experiments in psychology history that made these guidelines necessary. You've probably heard of them. The Stanford Prison Experiment, if you haven't heard of these, please look them up. This is one where a group of college students were assigned to either be prison guards or prisoners to see what happened. And very quickly it escalated into the students assigned to be prison guards treating the prisoners very, very badly. And it led to a lot of trauma, and this study was actually canceled really early. It had a lot of ethical issues and it wasn't allowed to be completed. Another set were Milgram studies. Again, look these up if you're not familiar with them. Essentially, he wanted to see if people would obey an authority figure, even if it meant hurting someone. So he led his participants to believe that they were causing other people harm, even though they weren't. They thought they did. And he was actually able to convince his participants to administer what they thought was a lethal electric shock to people who were in on the study and just pretending. But it caused a lot of psychological harm, and something like that would not be allowed anymore. The Little Albert experiment, again, look it up, was by John Watson, and he wanted to see if he could make a little boy be afraid of white rats. We'll cover the Little Albert experiment a little bit more when we talk about John Watson. But none of these studies would be approved today. We have gotten a lot more ethical guidelines than they had at this time, and these studies would not be allowed in any way, shape, or form. So the challenges of human research. Again, this is a very difficult science because we're not looking at machines, we're not looking at particles, we're studying humans. We are studying humans, not things. There are ethical issues, there's a lot of complexity, there's a lot of variables contained in one human, and it makes it really hard to isolate what you're actually looking for. Studying humans and actually isolating the variables you want is really, really hard. We have a lack of control. We can rarely have full control over the variables. We can't always have a control group. A lot of times we have to rely on naturalistic observation or correlational studies rather than experiments. And it can be difficult to see what we're looking for because we're not in a controlled setting. Descriptive research is incredibly useful in developmental psychology, but it can't give the hard findings of strength of association, cause and effect, etc. So because we can't control things, because we can't have pure experiments all the time, it makes studying humans a little bit more challenging. There's also something called the Hawthorne effect. The act of observing something changes it. Laboratory settings can have more control, but they may intimidate the child and therefore change the child's behavior, so you're not seeing the behavior as it would occur naturally. So maybe you decide to go into the child's house instead, or to their preschool, so you can see their behavior in a more natural environment. Well, even then, having a stranger watching them might change their behavior. So the Hawthorne effect is that the act of observing something changes it. Just by watching, just by studying something, we change it slightly. And you have to be aware of that. There are a lot of confounding variables. Again, we're studying humans. There are always more variables than we can control. In many ways, this makes psychology a more difficult science than physics or chemistry. It's hard to be sure the variables we're interested in are actually the ones responsible for differences or changes. There are just too many variables to consider. And since we're studying humans, and we are humans, we have to be aware of subjectivity and bias. Coding behavior can be subjective. And much of what we look at in psychology and child development can be subjective. For example, define depressed. Everyone's definition of depressed might be a little different. Define hyperactive. Someone watching a class full of students might rate a child hyperactive when another one watching the same class might not. It's subjective and there's bias. The definition for these things will probably be different for whoever you ask. Therefore, it's very important that variables be defined clearly and that all the researchers working on a study measure them the same way. It can be really hard to avoid this bias. And you also have bias in your participants themselves and the way they answer the questions. Even when the researchers are trained, subjectivity comes into play. So an example is maybe you're watching a baby for 5 minutes and you are told to count every smile. That sounds easy, right? But what one person defines as a smile, another person might not. Okay, so there are things called observer bias. Multiple people watching the same event will probably report it slightly differently. You see the same in eyewitness testimony. If you have multiple witnesses, they will all report a different version of events. Some might rate an expression as a smile that others don't. Some might see behavior as aggressive and others don't. The extent to which the different researchers agree on a measure is called inter-rater reliability, and it's really important to achieve that so that all the researchers are finding the same thing. You can also have this bias on the form of the participants, especially when they're asked to self-report something, like when they're filling out a questionnaire. Self-reports are used frequently, but they can also be subjective. Participants might have inaccurate memory, or they might give an answer they think the interviewer wants to hear rather than the truth. And interviews can lead participants to answer a certain way, even subconsciously. They may not even realize they've changed it. So this is just your overview of research methods. I just like to give you the basics of it. You'll encounter it in your future classes too. So if you have any questions about this topic, again, please post them on the Blackboard forum or contact me directly.